we would like to show that the derivative of sine z is cosine z, and the derivative of cosine z is negative sine z, under the assumption that the functions are differentiable. Because we're not going to use the definition here, we're going to use a theorem that says if a function f is differentiable, then the derivative f prime of z is equal to the partial derivative of the real part plus I times the partial derivative of the imaginary part, where both of these partial derivatives are with respect to x. Okay, so in order to use this theorem, we have to write the sine and cosine functions in terms of their real and imaginary parts. So the cosine, well, let's do the sine first. The sine of z is the sine of x plus iy. And then if you remember the sum formula for a sine, the sine of alpha plus beta, the sine of the first times the cosine of the second plus the reverse. So the cosine of the first times the sine of the second, and then the sine and cosine of a purely imaginary quantity. If we recall from previous chapter that if we look at the Maclaurin series, then we can see that this is nothing more here than the hyperbolic cosine of y, and this is I times the hyperbolic sine of y. So the definition of sine z is sine x hyperbolic cosine of y plus I from this one here times the cosine of x times the hyperbolic sine of y. So we have a real part, u of xy, and an imaginary part, v of xy, here. So the derivative of sine z, according to the theorem, is u sub x plus I v sub x. So u sub x, take the derivative of this real part here with respect to x. The cosh y doesn't have any x's in it. We treat that as a constant, like as if it was a 5. So the derivative of sine x times 5 would be cosine x times 5. So we have cosine x times, it's not a 5, it's cosh y, it's just treated the same way as a 5. And then we have I v sub x, so we have to take the derivative of cosine x, and the hyperbolic sine of y is treated like a constant. The derivative of cosine x is negative sine x, so let's change this plus here into a minus, and sine x times hyperbolic sine of y, and this is the definition of cosine of x plus iy, or cosine of z. So this shows that the derivative of sine z is cosine z. And now, using that this is the cosine of z, so this one is cosine of z here, let's take the derivative of that. So we have a new u sub x and a v sub x to consider. Let's call this one, let's use r and s instead of u and v. R plus is. So we want, the derivative is r sub x plus is sub x. So what is that? So the derivative of cosine z is the derivative of this real part with respect to x. That's negative sine x cosh y. And then the derivative of this imaginary part with respect to x is going to be minus I cosine x hyperbolic sine y. And if we factor out the minus, sine x cosh y plus I times cosine x sinh y then this should be negative sine of z. Sine of z, here it is. They match. They match perfectly. So we have shown that if the sine and cosine are differentiable, then using the theorem that says the derivative with respect to z of a complex valued function is simply the partial derivative of the real part plus I times the partial derivative of the imaginary part, where both partial derivatives are with respect to the first variable x. If we use that theorem, then we see that the derivative of sine is cosine, and the derivative of cosine is negative sine.